Hello. Today I am going to talk about the fundamental structure and architecture of the GPU, which stands for Graphic Processing Unit. Before we talk about the GPU, we need to know about the CPU first. The CPU stands for Centralized Processing Unit. Modern processing chips have all evolved along the basic structure of the electronic calculator that von Neumann proposed in his paper during the Manhattan Project. The current CPU-based structure has evolved based on the von Neumann structure. The von Neumann architecture is a structure with distinct advantages of flexible computing power. It is also a structure that allows organic association between the previous calculation result and the next calculation result through sequential calculation. The CPU is oriented from the von Neumann architecture to an advanced memory area such as control and cache. The goal is to efficiently execute various forms of complex programs by integrating multiple levels of cache. However, all modern CPUs have the same problems with serial executions. It's called the von Neumann bottleneck, which means that the result of every calculation must be stored somewhere in memory after an arithmetic logic unit operation, which stands for ALU. Because the results of the ALU operation must be stored in the cache inside the memory or chip, only one transaction is processed sequentially at a time. Even if you increase the clock to increase the processing speed, you can only calculate as much as the higher clock, since clock improvement have reached its limit due to heat and other problems. CPU development has been increasing the numbers of cores that can run simultaneously, such as multi-core and hyper-threading. And the GPU stands for Graphic Processing Unit, and it was originally developed for real-time graphic processing. It literally started out as a coprocessor to perform the bulk operations, which means like a lot of operations and time requires for graphic processing. Graphical processing typically results in a large number of vector space conversions, depending on how you assume the light and the position of the observer. This leads to a lot of shaders, textures, computations, and pixels rendering to be sprayed on the monitor. These operations vary depending on the graphics resolution or the degree of sophistication of the texture, but they produce an enormous number of floating point multiplication operations compared to typical CPU operations. You can use CPU to handle all the floating point multiplication operations, but all the processors based on von Neumann architecture are sequential, so many floating point multiplication operations will be processed one at a time. This would mean that important programs would actually be waiting to run simple operations. For example, when you run a game, but you cannot input your keyboard because you are drawing on the screen. In a basic architecture of current GPU, the one of the biggest graphic card company called NVIDIA, they made a architecture by themselves called CUDA. It stands for Compute Unified Device Architecture. It's a parallel programming model developed by NVIDIA in 2007. It supports parallel processing of applications using CPU and GPU. As a programmer-friendly parallel computing platform, it has greatly contributed to the increase in GPU utilization. Computer systems that process CUDA programs consist of a host referring to a general CPU or computer and a device referring to a parallel processor such as GPU. And the components of CUDA programs are host code, device code, kernel function, thread, grid, blocks. They are like big components in a CUDA program, and host code is a sequential program that is made in C language. And device code consists also a C language and a kernel function. And a kernel function is a code written in an extended form of keywords specifying parallel functions and data structures where the device executes. And the thread is an instance of a kernel function and executed by the CUDA's core of the GPU. And the grid is the entire thread run by a parallel kernel, and a block is unit divided into appropriate number of threads in the grid. And each of these elements are defined to be used to take one on the situation. The next is how they are really executed on the CUDA program. In the CUDA program, the host executes the sequence. I'll give you a simple example. The host executes a sequential code. Then when the kernel function is called, the parallel kernel code is sent to the device. In the device, the kernel creates a grid, which including multiple blocks and threads, and allocate it to the SM and to the SP, and the SM are responsible for each thread. When the execution of all threads is completed, the grid is terminated and the result values are transmitted to the host. The host executes the next sequential code, and if it encounters another kernel, it repeats the process 2 to 4 times. And the picture on the side shows the structure of storage for CUDA execution. Finally, we learned how CPU and GPU really works. Calculation requires for graphic processing do not require a complex instruction set or large number of registers. It also eliminates the need for complex cache structures. You just have to do the same type of calculation, floating point multiplication in bulk or like out of operations. The CPU has a sophisticated architecture for executing complex instruction sets. That's why he's a smart guy who can effectively run any type of program. But as smart as you are, smart as the CPU, the cost per individual calculation is high. The CPU can, of course, perform floating points operations, for example, 50 billion times, but it would be more efficient to do other complicated things at the time. A GPU is a coprocessor designed to allow a simple form of bulk computation to be independent of CPU. And GPU is more like computing distributed process rather than like CPU is just computing one process at a time. So it depends on the architect, which we can use CPU and GPUs. But mostly CPU is used to calculate the simple tasks, and GPU is to visualize our inputs or outputs. And this allows for low-cost bulk floating point operations required for graphic processing. Of course, the CPU can perform more important complex tasks while the GPU is working hard to make floating point calculations to draw on the screen. GPU was a... Thank you.